Satellite communication technology is rapidly evolving. And one of the most interesting recent technological innovations is the integration of optical data transmission technology into existing SATCOM networks. I recently had the opportunity to sit down with Darryl White of USEI and Jeff Huggins of Cailabs to discuss a new service from USEI called DiamondLink, which combines their existing network of ground stations with Cailabs' optical ground station and broadband data transmission technology to create the first commercial, global, space-to-ground optical communication service. You don't want to miss this. So, Darryl, let's start with this. What is DiamondLink and what's the driving force behind it? What caused you to create this?
So, DiamondLink is an addition of optical ground stations to our existing RF infrastructure globally, and really what caused us to develop this and start looking at optical and working with Cailabs is USEI is a small business. We've always been on the innovative forefront. That's how we serve our customers and stay ahead of technology. Understanding and listening to the customer's needs really is what's driving us to go down this path.
You know, if I may, I'm so glad you said that, customer needs. What sort of problems are you solving? What were you hearing from your customers that caused you to consider layering optical data transmission onto your network?
It seems like the advancements in space have always been the initiative, with the ground site being an afterthought. And so technologies in space are there, and the customers are now looking to benefit from those higher data throughputs, space to ground.
That's the primary thing, is the bigger bandwidth.
Correct.
Now, I understand, and please correct me if I'm wrong, that there are existent government platforms of this type, but this will be the first commercial network of optical ground stations. Is that correct?
Correct. And to me, or to USEI, it's a commercial solution that's going to serve both commercial and government needs. We see the government behind on some of the ground advancements and what they're doing to bring those technologies from space to ground, as well as what we're seeing from the commercial sector. There's multiple different customers that we deal with on the RF side, whether it be Earth observation or others that are have the technology in space, and they're now looking to utilize that and benefit from the increased capacity and the resiliency of offering both optical and RF together.
Yes, that's a big point, isn't it? Yes. It's not mutually exclusive.
Right.
Now, Jeff, as you know, I spoke with Jean-Francois from Cailabs on the show floor at Satellite 2024 last year, and I learned a great deal about the benefits of optical data transmission. Darryl and I were just talking about the higher bandwidth. I was wondering if you could tell us exactly how much higher that bandwidth is, and maybe touch upon some of the other benefits that optical offers over RF.
Sure, Frank. Thanks for having me on the show here, and happy to talk about optical. I guess maybe a starting point is that just about everybody involved in satellite communications is an RF person, including me. And but now that I'm at Cailabs and seeing what optical can bring to the table, it's the start of a new era. Having been in the industry for a long time, I've been looking at PowerPoint that's talked about free space optical and laser communications forever. And each one of them was only one PowerPoint deep. But there's a couple of technologies that have come together to really make it work now. Part of it you're seeing SpaceX and others talk about, that there's a network in the sky that is allowing communication between the satellites at 100 gigabit and 200 gigabit speeds. The other thing is just the volume of satellites that are up there. It wasn't but just a couple, maybe 5 or 10 years ago, there were just a couple hundred satellites, and now there's thousands up there. So the fact that there's all that data, all those satellites, and they're able to move the data around between the satellites all are enablers for the optical situation. Bringing that stuff down to the ground right now, RF is in the hundreds of megabits. There's some exotic ways to get it up a little higher, but it's hundreds of megabits. The commercial solution we're delivering right now is 10 gigabits per second coming down. So just a huge quantum leap. And the physics allows us to get up to 1 terabit. And so
wow, I did not know that.
When you have all that data up in space, and it's going to keep getting more and more, optics is what you need in order to overcome that bottleneck that right now is there with the RF, or the limitations of physics on what the RF can do. So bandwidth is a part of it in how it works. It partners with RF. It's not going to replace RF. The other thing with optical is as all these satellites are going up in RF, there's a limited spectrum allocation, and everybody has got a floor of lawyers to try and advocate to get the spectrum that they need in order for their satellites to operate. And now we're even fighting among the satellite operators, the GEO versus the LEO, on causing interference. Optics, because the signal is so tight, doesn't require any special regulation associated with it. There's the reason for the regulation is so that there's not interference. And when it comes down from LEO, it's only 12 meters in diameter. So the other thing that does is it has low probability of intercept, low probability of detection. You talk about trying to jam a satellite signal, and one of my colleagues, Army background, says, when you're talking 12 meters, if you're going to be within 12 meters of it, you might as well just throw a hand grenade. So the idea that it's just a different technology that has all sorts of different advantages that can really nicely overlay into RF. Where you can position the ground stations, you don't have to have them up in Svalbard on an island that is half administered by the Russians and half administered by Norway in order to catch the satellite each time. I mentioned that technology that allows the data to flow between satellites. So now you got the flexibility to put the satellite ground stations in locations that are geographically convenient. You can put them right next to your data center. You can put them in sunny spots anywhere in the world. So they can be protected so that they're close to where the customer is. You don't have to pay the big fees to have the connectivity to get it across long distances. You don't have to be in a RF quiet area in order to use them. But at any rate, so it's an exciting thing that I think the market is ready for, and I'm excited to be at Cailabs talking about it.
Yeah, I can feel your passion for it. And I actually had not considered the whole spectrum allocation and regulation aspect of it, something I have a lot of familiarity with. Now, Darryl, how, literally from a nuts and bolts standpoint, how are you guys going to do this? Are these optical ground stations going to be built next to your existing dishes, or how is this going to work from a physical standpoint?
So from the onset of this, yes, we're going to initially pick the locations that have the best availability time for optical, weather related, everything else. We're a hardware company. We're on the ground, and if a customer needs a specific location, that's where we build it. It's serve the customer need, and the more we do some of the testing and stuff with Cailabs on proof of concept and serving out some of the validity of this and the customer needs and testing with their baseband equipment, we'll find the right locations that, based on the customer's needs again. So we're an open teleport concept that's what we try to do is serve the customer and hopefully keep the customer cost down. So if we can install at existing teleports where the customers are already customers of ours with all their baseband equipment, the Cailabs technology integrates well into that. Okay, they may have to increase the terrestrial backbone or whatever we need to get that data throughput. Now the capabilities improvements, but the baseband equipment really doesn't have to change a lot, and it's keeping the cost down for the customer and picking the right locations.
That's great. Focus on customer needs is always a winning strategy.
Yeah.
Now, speaking of customers, and let me start with you, Darryl. What sort of customers will you be targeting or offering this service to?
Both government and commercial. Jeff knows we've been talking with a lot of different government agencies, and as well as on the commercial side. There's I mentioned Earth observation earlier. That's been a big one on the commercial side, and it seems like there's multiple different groups within the government sector that are hitting us. So.
Okay, and Jeff, do you have any specific? I know, for example, with the three-letter agencies, one of which I heard recently referred to as no such agency. You can't speak to exactly whom you're serving, but either on the commercial side or government side, what sort of clients has Cailabs found a lot of traction with so far with this optical data transmission?
So there's a lot of people that are starting to move into the optical capabilities, and the Space Development Agency, for starters, has put 356 satellites on contract through their Tranche 0, Tranche 1, and Tranche 2 that all have a optical communication requirement to communicate with the ground. So all those satellites are going to be up in the coming months and available to send data to the ground. And so having a ground station is a part of that. I should mention the other technology that has matured is being able to deal with atmospheric turbulence. Sending the optical signal between the satellites with no air or atmosphere it doesn't present any distortion to the signal. But as you come through the atmosphere is where you have to have a little bit of technology to do it. The adaptive, there's an adaptive technology where they flex the mirrors in order to get the signal. It's been around for astronomy for a long time, adaptive optics. And so you look at a star, you flex the mirrors until you get a good picture, and that's how they're able to deal with the turbulence in the atmosphere. The capability that Cailabs brings to the table is a passive one, and I think that that's why Darryl and his team picked us to be the product that they're going to use, because we use a mux and demux process that's completely passive. There's no mechanical mirror shifting or anything, so we can follow a satellite 7 minutes from horizon to horizon. And keep up with it. The in situ measurements over New York are a lot different over Chicago, and as the adaptive optics program is trying to flex mirrors to make that happen and keep up with that pace, the signal it works in the lower ranges, but when you get up to 100 gigabits and such, you really need to be moving faster and be passive. And so, at any rate, that's where we jump in and make all that happen. As I mentioned, the SDA has 356 satellites. They believe in optics because they put those requirements on the satellites that are going up there. The constellation providers, there's a couple of them that we're working with. And since the spring of 24, we've been connecting and receiving data from both allied government satellites as well as some constellation satellites.
Great. Now, Darryl, what sort of a timeline are you guys looking at as far as the rollout of this?
So we're looking at the first optical ground station rolling out in late 2025 and additional terminals in 2026. And
so I take it there'll be some testing and making sure, all Correct. The T's are crossed and I's are dotted and so forth.
Yep, and I kind of see, and Jeff, chime in on this if you see differently, but to me, I see the first kind of 18 to 24 months doing a lot of R&D and proof of concept with customers, doing all those testing phases. And then from there, rolling into a service offering. I think the front end of this is going to be loaded with a lot of the proof of concept, validation.
Right. I can see where when you combine these technologies or layer the optical data transmission on top of your existing network, that you can turn that right into a service. Would you like to tap into this, Mr. Customer?
Right.
What sort of technological or marketplace evolution do you see, Jeff, happening over, let's say, the next 5 years or so?
Well, I think it starts with those 356 satellites that are up there, and there's a number of customers like Darryl's team that have come to us to establish a network. And as there's more of a network established on the ground, and there's more option, there's going to be more satellites that go up that depend on optical or are going to take advantage of the optical downlink. There's a lot of business models that in satellite service providers and that talk about price per bit. And how much time you have to allocate to an individual antenna. When you're talking about bringing 10 gigabits down per second versus 100 megabits, the math works pretty well if you're trying to make a business model. And so, I think we're there. I think that Darryl and his team are on the front end of this, and I think there's more and more that is going to unfold in the next months and years.
Darryl, obviously you've been working with RF customers for a long time, and the potential exists for this to be, dare I say, a revolutionary change in the way data is transmitted from space. As a result, especially after you guys prove your concepts and you have a couple of successful case studies, what do you think that people who are watching and listening to this should be thinking about, the leaders, the mission managers, that so forth, who need to plan for the future? What sort of things should they be thinking about in their planning for the next few years?
I mean, data requirements just continue to increase, and to get to the level of data throughput, and Jeff touched on it earlier. It's optical is really that means to the need. So, I mean, it's location. It's who, what is the demand? What is the resiliency requirements? And that's, I guess, when we're looking at it from an infrastructure company, just being a ground station service provider, is, we want to be the key element to the success of our customers. We don't compete with our customers. We keep an open teleport mentality that, we will serve any and all, and we'll support them in any of their solutions. It's whether it's a RF optical combined solution, if it's an optical only, RF only solution, those are the things that we do. And I guess for customers thinking about the future is, I mentioned the proof of concept in R&D. That's one of the strengths of our team is where we've been innovative and as a small company, very nimble, being able to react to some of the industry changes and stuff, and supporting even potential customers in their R&D and proof of concept. That's one of the things that has helped USEI evolve through the years and stay, I guess, at the forefront of technology changes as a small independent company.
Jeff, that's such an important question relative to what business leaders should be thinking about and integrating into their plans into the future. What would be your reaction to that question?
Well, I echo what Darryl said, that the data flow is going to get bigger. I mean, every time over the last 10 years that people have tried to predict how much data is going to be flowing or how much they're going to need, they've been off by a factor of 10. I mean, it is just amazing how much data is flowing. And then the other thing on top of it is what it unleashes. Right now, given the downlink capability, people are limiting what they're gathering for sensors up in space. And so if you have a huge pipe that's now ready to come down, it opens a whole wide view of what sensors now you can put up there, or what data you can collect about the Earth, or about the planets, or about other satellites up there. So just different sensors can come on, and more data and more satellites. And I think that's what the future is. And I think that's what leaders need to look at and bet on, is that there's going to be more data up there, and there's got to be ways to get the data down, and latency is going to be important. And optical is how you step around that latency. If you're moving stuff at 100 gigabits, it suddenly makes latency go away.
Jeff, you touched on a really good point there with the data throughput and that, and I think it really is going to turn into, when we're able to pull down all the data instead of selective data, then you end up creating more challenges on the ground. I mean, now you got to start looking at the edge compute and how am I analyzing all that data, and so it creates other good problems because now we got the data we need, but now how do we process that data and make it useful as well? So.
Yeah, and I think AI, the way AI works is it's got to have lots of data to look through and can make sense of it. And so if you've got lots, that means more data has to move around for the large language models or whatever AI application you're talking about. So it all is just driving more and more data is gonna be happening, and adding optical into as Darryl and his team are leading the edge, are on the leading edge of doing, is I think the way of the future.
I'll tell you, I am so excited about this. As I told both of you guys just before we started, this is what we call a real story in the news business. And I'm happy to be able to share it with my audience. Now, naturally, I'm going to put links to each of your company's websites where people can get more information about this. But let me ask you first, Darryl, where else might people look to get more information about DiamondLink?
I think the best locations right now is on the USEI or Cailabs website, which you said you're going to post. I guess for folks that USEI is going to have a big presence like we normally do out at the Satellite 2025, and so we'll be there. I'm thankful for the industry and the selection. USEI was nominated again as Independent Teleport of the Year. So we're one of the top three finalists of that. So we're definitely going to be at the WTA luncheon. So there's, and around the satellite floor. So if there's, if you see us, we'll have our team there and we'd be happy to sit down and chat there as well.
I will certainly stop by and say hello myself, as I will be there. And how about you, Jeff? Where can we learn more about Cailabs?
Well, I think our website is a good starting point. And, what's also put on our website is a number of the white papers that we send out for peer review. I mean, we've got 135 people that work at the company, and 36 of them are PhDs in optics. So it's a lot of people that are really smart and really excited about shaping the light. And part of what they want to do is move the capability forward and share that information across the industry. There was a Photonics West is the center of the universe for optics at the end of January out in San Francisco, and it's every optics geek in the world tries to make it there. And we presented, I think, 9 papers and talks during the course of the 4 or 5 days. So we're excited about it. You can pick up that excitement on our website, and if you really want to dive in, there's white papers and theses that'll give you lots and lots of detail about how it all works and give you confidence that optical communication is real. It's something that works and that is going to make a difference.
Darryl White and Jeff Huggins, thank you so much for joining me today.
Yeah, thanks for having me, Frank.
Thanks again to Darryl and Jeff, and thank you for joining us. Until next time, I'm Frank Felker saying I'll see you in space. The SmallSat Revolution podcast is powered by GomSpace. With platforms, components, systems, and services to meet every SmallSat requirement, GomSpace brings their innovative technologies and a flight heritage of over 2,000 successful deployments to your next mission. GomSpace, leading the SmallSat revolution. Learn more at gomspace.com.